Hello, welcome back to another video. I'm glad you clicked on this one, mainly because you're required to. However, we are talking about even and odd functions today. Again, this will seem familiar from Algebra 1, whenever you talked about polynomials, really kind of like your second semester of Algebra 2. But today is even and odd functions. Really, there's symmetry behind them and how to find out what they look like graphically and what they look like algebraically. So when I say even, you say odd. So even, I'm going to trust you said odd as well. So ideally, by the end of this, let me move my little character out of the way. You'll be able to discuss the symmetry of even and odd functions and determine algebraically how a function can be even or odd. And I should have put or neither in there as well. So we'll talk about what that means and what that looks like for them to not be even nor odd. So when I discuss symmetry, there's actually four different types of symmetry. Symmetric about the x-axis, about the y-axis, about the origin, and actually about the line y equals x. Now, we're going to be concerned primarily about symmetry about the y-axis and being symmetric about the origin. We don't need to cover the x-axis, and actually, you have covered symmetry about the line y equals x in Algebra 2, and you will revisit this in pre-cal as well. And in case you forgot, symmetry about the line y equals x is actually an inverse function. That is a topic for another day, but for now, what do I mean when I say some symmetry about the y-axis or symmetry about the origin? That's the only two we're worried about today in this lesson. Well, I don't think I should explain. I think I should bring in a guest. He's a very busy businessman. He owns a lot of property, owns a lot of things, and I pulled a lot of strings to get him here. So I want you guys to give a warm welcome to a very special guest. Come on in. Come on in.
Howdy there, folks. My name is Mr. Palmer. That's right, you heard me. Mr. Palmer. My granddaddy's name Mr. Pre-Calculus. My daddy's name was Mr. Farmer. That's why they call him Mr. Palmer. Now, I'm a very busy man. Work 8 days a week, 48 hours a day. I own a couple real estate places around town, as in the local zoo, local farm, local wildlife exhibit. I also own a couple of pastry shops and a haberdashery for my kangaroos. Now, I took time out of my day because I respect that Mr. Garcia a lot. See, he has come through to teach math to my animals at my zoo to make them the smartest animals within the entire United States. And that's a fact. So I respect Mr. Garcia. So when he asked me to talk about this symmetry, I know a couple things about symmetry. Okay? All my animals are very symmetrical. I actually have a couple animals here to show you today to show what I mean when they're symmetrical. All right. So this first critter I got. Some call it a cat. I call it a big cat. Now, he's kind of quiet. He's kind of shy, so he's not going to speak. But this other animal we have here, he's not afraid to speak. Constantly he's talking. He's constantly talking. This is another one of those cats. Not really sure the name of this feline it is, but it often says meow, so I think that's his name is Meow. Um, I don't really know what this thing is. It was lost, but I found it, so thank goodness for that. And I'm trying to get rid of these critters. I have a bunch of these critters just running around my place. Like I found this thing and I killed it, and these little suckers always running around. And as a little warning, if I keep seeing a bunch of these, it's it's of these. And I think that's about it. Yeah. Sometimes I got these chickens to feed to my guard dog right there. You can see in the background. The little chickens. They love to, like I said, just little chickens love to be fed to little chickens to be fed to your guard dog. Now, today's about symmetry. Okay? Happen to have this contraction known as a whiteboard. Now help us out right now. Okay? All right. Now, we're focusing on two types of symmetry. Okay? Symmetric about the y-axis and about the origin. All right? Now, when I talk about the y-axis, that means you got some point AB. Okay? And you take that same point AB, if it's symmetric across the y-axis, there's also the point negative A comma B. So we know this. We like this. I sound like Barack Obama. Good old parabola. Good old y equals x squared. All right. Now, growing up, we didn't have this. We had to draw in the dirt ourselves. In fact, we had a lot of these. A lot of symmetric about the origin. That means you got some point A comma B. You can take that same point if it's negative A comma negative B. We got ourselves a graph that's symmetric about the origin. Now, commonly, there's a bunch of different graphs. One graph that you may know of, that good old rational, all right? That good old 1 over x. Got an a comma b. If you also got a negative a comma negative b, boy, you got yourself a symmetric about the origin. Now, again, there's about two other symmetries we will not cover, according to Mr. Garcia. That being said, that's the only two we need to worry about now. You hear me? Now, my name is Mr. Palmer. That's all I have for you folks today. I got a wildlife exhibit to work on. A lot of folks calling me Joe Exotic. Now, I ain't no Joe Exotic. I am the man before Joe Exotic. More dignity, more respect. All right, you hear me? This is Mr. Palmer. I, this is Mr. Palmer. I'm out.
Wow, what a special guest we just had. Well, Mr. Farmer, again, thank you so much for coming out. Make sure to check out his zoo, his farm, and his haberdashery, especially if you have a kangaroo at home. I know he'll really appreciate it. I know he is very busy out of himself, so it was such a great honor that you were able to stop by. Thanks again. Have a safe drive home on your horse carriage. So what Mr. Farmer was talking about was there are two different types of symmetry we're going to discuss this semester. Now, the first symmetry is symmetric about the y-axis. So there's the picture that he showed, this one here. And that's really the definition. It's like, hey, if you got some point AB on the graph, then that means if it's symmetric about the y, you also got the point negative A comma B. So if that AB is like, I don't know, 5 comma 3, that means you also have negative 5 comma 3 on the graph. So the parabola y equals x squared is a very common one that we know. There's also just another type of quadratic. We'll talk more about the specifics of the equations later, but for right now, I just wanted to understand more of the concept in of itself, and also some trig. You will do a lot of trig, especially in the second semester. So I want to expose you slowly to any type of trig I can. Specifically, that is a sine function. Okay. No, sorry, my bad. That is a cosine function. That is not a sine function. That is a cosine function. Symmetric about the origin. So the picture, let me see here. Yeah, the picture that he showed, Mr. Palmer, is like, hey, if you got some point A comma B, let's say again it is 5 comma 3, then you also got the point negative A comma negative B. So if you have 5 3 on the point, you also have negative 5 negative 3. The way it's symmetric about the origin, let me get the laser pointer out. Well, first off, I forgot to mention here, when we say symmetric about the y, it's essentially like a reflection across the y-axis. Okay, so think back to reflection from geometry. Same thing here, except that it's two reflections happening. It's a reflection across the y and a reflection across the x. Now, you should have covered reflections in Algebra 2 as well, but it's just another way to kind of think about what's happening whenever I say symmetric about the origin. There are two reflections happening, reflection across the y and reflection across the x. So these are two different types of graphs. Again, this is just a polynomial, which we'll discuss more later. And this is the sine graph. Again, my bad, I got those two mixed up. But there are different tests that we can do. So when talking specifically about symmetry about the y-axis, the more formal definition is
We'll have symmetry about the y if we get an equivalent equation with all the x's replaced with negative x. That essentially is just saying replace x with negative x. Simplify the equation. And then if your resulting equation is equivalent to your original, boom, you're symmetrical about the y. A couple things about that is this is often called an even function. This is often called an even function. So when I just say, hey, what's an even function? I'm talking about it's symmetrical about the y-axis. The way to kind of sum it up, which I'll have this on the following pages with the examples, just as a little reminder. If f of negative x equals f of x, that means f of x is even. Okay. So again, if I plug in negative x to my function and I get my same function I started with, got an even function. All right. Um, Symmetry about the origin. Okay. So very similar, except that you replace all the y's with negative y and all the x's with negative x's. Why do we do both? Because that's the definition of the symmetry about the origin. Remember, there's a reflection across the x happening and a reflection across the y happening. There's two reflections happening with about the origin. So we need to take account for that whenever we solve it algebraically. So that means we replace y with negative y and x with negative x. See here, and then we simplify the equation. Same thing. If the resulting equation is equivalent to the original, boom, we got symmetrical about the origin. This is called an odd function. All right. So symmetrical about the y is even. Symmetrical about the origin is odd. And if we want to put it in function notation, if negative f of x equals f of negative x, then f of x is odd. Notice here, I didn't really go the long route with this. This first bullet is covered all in here. So it says replace y with negative y. We're doing that here. And x with negative x. We're doing that here. Okay. So if this statement is true, that means we got an odd function or we got a symmetry about the origin. Okay. Now there's different ways to kind of go about this. Let me move my little person out of the way. Is that possible? Hey, there it is. Cool. So let's determine whether this function f of x equals 3x minus 6, f of x equals 3x to the 6 minus 1 is even, odd, or neither. So if I don't fit any of these criteria, that means it's neither. So if you look at these, notice the common thing is f of negative x. So the test you'll see me do pretty much every single time is find out what is f of negative x. If I do f of negative x and it equals f of x, boom, we're done, it's even. If I do f of negative x and it doesn't equal f of x, well, that means it's not even, and there's a chance it's odd. So when we get to that, we'll get to that. But for right now, let's just evaluate this one here. So again, determine whatever it's even, odd, or neither. So first, let's find out what is f of negative x. Remember, we just did function notation and composition. So anything inside the parentheses is going to be plugged in to our function. On this first one, you're going to see me do something very repetitive. I will not do this every single time just to save us some time, but I want you to make sure you understand what's happening whenever I do this, okay? So here, I plugged in negative x, every place it's on x. And now I need to simplify this. Well, I need to work out negative x to the 6th power. So up here, again, you don't have to write this part down if you know what it is, but I'm going to show you what it is. This is saying negative x to the 6th power is you're taking that negative x and you're multiplying it by itself 6 times. 3, 4, 5, and 6. Yeah, okay, cool. So we just got to work it out. Now, here's where our good old negative, positive multiplication rules come in handy. So here, a negative times a negative, that's going to be a positive. Okay. Then we got, so I'll just say a positive right here. Okay, this negative times this negative is a positive, and then this negative times this negative is a positive. That's an x. What? So I will figure out the exponent in a second, but I at least know that this result will be a positive number. I'm multiplying a negative times a negative 6 times, and I'm ending up with a positive value. In this case, I mean, it's just going to be x to the 6 because they're all exponents of 1. So this first part here is going to be 3 times negative x to the 6, which is just 3x to the 6. So if you notice about this, oh, that mark shouldn't be there. I apologize. If you notice about this here, after I apply the negative x to my function, notice I get the same thing. Notice I get f of x. So here's what I'm saying here. Let me get a pen. That is the same thing as f of x. So we're effectively just saying this. F of negative x is the same thing as f of x. When we have that, that means we have an even function. Now, for the sake of example, I'm going to show you why it's not odd. You can just stop there and say, hey, you're done. Because you can clearly see that it's an even function by plugging in a negative x and you're getting f of x in the end. I'll go ahead and show you why it's not odd as well. Test for odd, large pointer, negative f of x. So if I take a negative on the outside and distribute it to everything for f of x, after I do that, if I get f of negative x, that means it's odd. So if I do this and I end up getting this, this, that means it's an odd function. So when I do this here, cool. So negative f of x is 3x to the 6 minus 1. Well, negative on the outside, that means distribute that negative to everything on the inside. And hey, let me get the laser pointer. This is clearly not the same thing as this. That means it is not odd. You could have stopped after you did the first thing, but I want to make sure we understand why it's also not odd. Perfect. Next function, f of x equals x to the 5th. X to the 5th plus 2x cubed plus 3x. Again, I want to start off by doing f of negative x. Now, it replaces c and x. Replace that with a negative x. 3 plus 3 times negative x. Perfect. Again, I'm going to do this. This may seem tedious, but I'll stop doing this after a little bit. Negative x to the 5th means the same thing as negative x times negative x 5 times. So that means here, I know it's going to be to the 5th power because all those x's have an exponent of 1. But it's going to be positive or negative. Well, these two right there will give me a positive value. Okay, these two right there will give me a positive value. Oh, I'm going to have a positive times a positive. Ooh, times a negative. So that means here, I'm actually going to end up with a negative value. So negative x to the 5th. Okay, cool. What about this cube? Oh, it's going to be the same thing. It's going to be 2 times negative x cubed, which is just negative 2x cubed. Again, what we did here, in case you didn't see it, is 2 times negative x cubed, which is just negative 2x cubed. And then 3 times negative x would be negative 3x. Question for you. Is this function the same as we started with? It is not. So that means here we don't have an even function. So let's check to make sure before we say, oh, it's odd. Let's check to make sure. Because again, there's a possibility that it can be neither or neither. I don't know how to pronounce that word. So how do we check if it's odd? Well, we do negative f of x. If this ends up being the same as this, We're good. We're set. We got an odd function. So negative f of x, that means negative, parentheses, all of our f of x function, negative x to the fifth, 6 cubed plus 3x. So again, negative on the outside, stuff inside, distribute that negative. We're generous. So just switch your signs, and hey, this is the same thing as what's up here, isn't it? And up here was f of negative x, so this is saying here, oh, my bad. This is saying that that is f of negative x. So that means we actually have an odd function. Now, I do want to speed things up here by pointing out one thing. Whenever we had an odd power, and whenever we're doing this, we're end up with a negative. Okay? But whenever we had, let's say here, that even power, we're ended up with a positive. And again, it doesn't really count here. So that means here essentially, when I try out this next one, and I try out f of negative x, 9 negative x to the 6 minus 9 plus 4 to negative x to the fourth, instead of having to write out negative x times negative x times negative x 6 times, I know that whenever I have an even power, it's always going to be positive in the end. So 9 times negative x to the 6 is going to end up being 9 times x to the 6, which we know that is just clearly 9x to the 6. Again, whenever you have that even power, that means it's going to come out to be positive after you multiply. And let's just finish out the rest. So that's negative 9. Oh, hey, again, 4 times, what is this here? Negative x to the fourth is now just going to be x to the fourth. Again, you'll have a bunch of negatives multiplied to be positives. So we know that to be just 4x to the fourth. And hey, look at this. This looks really familiar, right? Looks like this is the same thing as the function we started with. Again, it looks like the function that we started with. So that means f of negative x equals f of x, which means we get ourselves an even function. Now, I'm not going to test the odd because I know it's even, so there's no need to test this odd. I know that it won't be odd. Here, next one, again, try that negative x first. Okay, I believe we have like 2 more, this one and the next one. So negative, some double negatives here, negative x cubed plus 5 times negative x to the fourth. Okay, let's apply that little shortcut we did last time. We're saying anything to the odd power is going to end up negative, and anything to the even power is going to end up being positive. So this thing here, just bring that coefficient out on the outside. This thing right here, since it's an odd power, that actually will still end up becoming negative x cubed. But this, and then bring that 5 on the outside, this negative x to the fourth, since it's an even power, that's going to end up becoming positive, x to the fourth. Oh, but we have here a negative times a negative, so that would be just a positive x cubed plus 5x to the fourth, and oh, we're close. We were close to being the same as f of x, right? It's just that x cubed in the front that messes up. Here, this x cubed is not the same as this negative x cubed plus 5x to the fourth. Okay, so it's not even. Before you say it's odd, we have to check. We have to check if it's odd. So again, to see if it's odd, we're doing negative f of x. If I do my math and my algebra, and I end up getting this expression here, we got ourselves an odd function. But let's try it out first. So here, negative f of x, so negative plug in your f of x, which is negative x cubed plus 5x to the fourth. Hey, this looks promising, right? Because when I distribute this negative, negative times a negative x cubed is x cubed. Oh, but a negative times a 5x to the fourth. Oh, that's weird. Is negative 5x to the fourth. Yikes. So it was very similar, but not all the way there. So that means here we actually fail both of these tests. So we don't have an even or odd function. We have neither. I think that's how you say it. Or neither. Maybe it's cultural. Last one here, determine whether the function f of x equals 3x plus 1 is even, odd, or neither. We'll say neither. F of negative x, again, this one isn't too bad. 3 times negative x, fun fact, is actually negative 3x. So is that the same as my starting function? Say it out loud. It is not. No, that first term is messing me up. That means it is not. Let me get the red. It's not even. Okay, let's try to see if it's odd. So that means negative f of x. So negative f of x. So when I distribute that negative, negative 3x. Ooh, a negative times a positive 1 is negative 1. We were close. We were close. If this was the same as this, it would have been odd, but since it is not, excuse me, that means it is nether. It's the third way to say it. So this is just one way to view it algebraically. I know we really didn't cover graphically too much, but that'll be for next time. And I'm not talking about it too much on this lesson for a specific reason. But this is how we determine for even and odd functions. Again, our goal really wasn't to do symmetry about the x-axis or symmetry about the line y equals x. That's just for a later point. We just don't have time this semester to cover it. But this will come in handy for class on Thursday and especially for next week. We'll try to figure out some other ways we can shorten all of this. But for now, if you have any questions, let me know. If I need to contact Mr. whatever her name was again, totally forgot. Sorry, I'm just starstruck. Like I just forgot his name. That's why. Let me know, and I'll contact them. So have a great rest of your day. I will see you in class on Thursday.